We are not for the DNA genetics modifying them, because what we are doing is actually weakening the species. So look at Dolly, for example. She ended up getting cells 6 years old, and she was just born, and by the time she was like older, she had arthritis, which weakened her, and she couldn't move or eat. She was force-fed.
This is not built in a day. So how do you think that genetic modification can be perfected in one try? We're going to start gradually and go up with something small, and we're going to go to bigger things. We're not going to start off on humans. We don't want to start off with that. We're going to gradually go up, and nothing starts off perfect in first try.
There's so much we don't know to genetic engineering. We're like monkeys playing with rocket science. We don't know what we're trying to do. We don't know if we're trying to make them glow, if we're trying to make them stronger, if we're trying to make them resistant to something. We have no idea what we're trying to do. So even if you do have an idea of what you're trying to do, how are you going to do that? There's so much that we can do, but there's so many cons that take from what you do.
How are you supposed to learn what to do if you don't try? Trial and error. It's what science is made out of. You don't always get it correct on the first try. You keep going. You got to lift yourself up. You keep going, and if you figure out what you want to do by trying, and even though that may affect, you might want to start small. Like, try going through a fly's DNA, because they're annoying. And then you can see what to do, and then you can learn and adapt to that.
Even if you do perfect the DNA modification, you are always going to be taking something out, because you always have a certain number of DNA and chromosomes and everything. So you always have to take something out and place that thing in, so which is really still weakening our species. We're taking something out that we have adapted to, that we know perfectly, and we're placing something else in. Even if we have perfected that, we're still taking something out and weakening us.
The thing is, with genetic engineering, that, we say this a lot, but practice does really make, things perfect. But, perfect is kind of, false sometimes. But, when you say you have a disease, you're saying that when you take something out, if you're still messing with it, that makes us weaker. Well, the thing is, if we continue to practice modifying things, we'll become, amazing at it, and that wouldn't really matter in the long run. Well, not long run, but it wouldn't really matter, because you still have something to combat your, decision you made to possibly have disease in there.
Exactly. There's nothing to fight a perfect cancer.
Something some kind of microbiome that both of us should take all the cancer cells, where if that little thing malfunctions, you build up or something or just any cancer things.
We brought the technology used and changed the universe.
So our Earth and all of its species have survived for billions upon billions of years, and we've never needed science to help out with that. I mean, isn't it the imperfect things about each and every species that makes it so strong?
I think the argument is really about genetic modification, and the one successful trial was Dolly, but the reason why she died was because she got arthritis from her mother, since it was an exact clone. So if we could get a perfect species to clone from, then the other one that we cloned would be perfect and then wouldn't die from arthritis.
I would like to say one thing before it goes back over. The dinosaurs. When that asteroid hit Earth, I don't recall them living. So what if something like that happened to humans? We should be ready for something that will happen in the future. So say a natural disaster happens, kills most of the human race. We should be able to have more humans.
Okay, so for Ashley's point, she was talking about cloning, and nothing is ever perfect. No human is going to ever be perfect. No matter what you clone, there will always be imperfections. The cloning part will either kick out a certain thing of DNA, or it might mess up and put in extra DNA that you didn't want or anything. It will never be perfect. You will always have something you will not want, because of the humans being cloned from. The human is never perfect.
Well, for Caleb's point, cloning is making a replica of what you are cloning. And if something does happen where the human race goes extinct, what can a clone resist that a human can't? Cloning is taking DNA from one thing and putting it into another. So if you take DNA from a human and try to make another human out of it, it's going to have the same characteristics. So with the characteristics, what can't one with those characteristics reject or keep off that the other one can't? It's the same.
Now, we are talking about cloning humans, but we're also talking about DNA engineering, which means that we don't have to make it an exact clone of ourselves. We could put different DNA into the clone so that it is prone to what the problem could be.
I just want to say, I'm not sure who made the point on the other side, but you were talking about many species have lived for all these years without science or whatever of the engineering, but many species haven't. Many species went extinct or died of diseases or stuff happened that all these species got wiped out.
A point to rebuttal Caleb's. If you make a human better, how is that going to stop a big, huge rock from outer space smashing your face open? How is that going to stop you getting swept up in a big tank?
Callum's point, if there was an asteroid that's coming to Earth, it's going to kill all of us anyways. So regardless of your natural selection versus our genetic engineering, we're all going to die. And so there can still, have the best of both worlds. You can do, have your natural selection and your genetic engineering. But either way, I think your point was invalid because we die anyhow.
I'm going to go on to Adriana's point. And if you're going to make something better by putting DNA into something else, right? What if the body rejects the DNA? What if it kicks it out? Then that's just an empty spot right there that is going to affect the whole species and animal, right? It's taking something out, putting something in, the body doesn't accept it, rejects it, it kicks it out, you have nothing there. What's going to fill up that space? You die. There's something. You get disappointed or something. Yeah.
That is why we need to start working on this now. So then when that natural disaster does happen, we can be ready so that it doesn't reject the DNA and that it is able to accept it and be able to work with the body that it is in.
You guys were talking about natural selection and stuff. That brings us to the point of survival of the fittest. Our world was created and all of the ecosystems and all the species work together. And the strongest survive because they, them at the top, then that helps the other ones go because there's species that protect other species. But if we start changing that, then the entire animal kingdom and all of this stuff falls apart because if we make a certain plant grow, now the predators of that plant will no longer want to eat it because it's not that plant anymore, it's now a glowing version. So it will mess up the entire animal kingdom, which will eventually make it all kind of fall apart and crumble.
So does that mean when you have your cows, I don't know the proper term, sorry about that, but when you have your cows and you breed them, that's kind of a form of genetic engineering because you're, picking this one because it has the best traits and you're picking this one because it also has the best traits. And you put them together. That's what we want to do with genetic engineering. But, there's a higher chance of us, making it almost perfect because we could be doing it. And so, because, a cow could die, and that would end. But, yeah, so basically what I'm saying is that's almost the same as genetic engineering. And as far as I know, it doesn't seem to be anything wrong with, taking your best cow and other best cow and putting them together. It kind of just makes a better cow.
So Caleb was talking about how you don't clone, you genetically engineer. Where are you going to get the DNA from? If you take DNA from something and put it into another, like say you take DNA from a wolf and put it into a dog, thinking that dogs will be able to hunt better. You take a certain trait, then does it actually work? you say that dogs can't withstand anything that a wolf can't withstand. Making it different is completely wrong. A dog was made the way it was made, and that's how you should keep it. But where are you going to get the DNA to make the dog better? From a wolf. What's going to happen to that wolf after you take that DNA out? The wolf then becomes weaker or dies. Then that completely corrupts the system.
We have chosen which sides we have agreed with. Now, we will come to our concluding statement with hashtag Sci9.
So with genetic engineering, we can never be perfect. No human will ever be perfect. But we can get close. We can find a medium in between and get close to becoming a species that can resist most at what life can throw at us, like disease and stuff like that.
My turn? Okay, so Neanderthals basically went to Homo sapiens, which are all of us. And we are so much more intelligent than they were. And that really only happens through natural selection. So basically, natural selection causes the next step in human evolution. And that makes us stronger as a species.
Even with genetic engineering, we aren't going to get more perfect. We aren't going to get closer to perfection in humans. Because really, you're either putting too much DNA in, which is creating more chromosomes than the human body holds naturally, which will create bad stuff. Or you're either taking stuff out of the human body that the humans are used to or need, and putting new stuff in that will just either go good or bad, but either way, it's still taking stuff out or adding too much. And it's just not going to get any close to perfection. It's either going to stay the same or go away further from perfection.
So we never said that we would add more or less chromosomes to our bodies. We would be keeping it the same, and we would be keeping it like at the regular 46 chromosomes that we have right now. We would take one out, we'd put one in. I feel that the DNA we should be changing in our bodies is maybe inheritance traits that we take from our parents. Weaker traits, like, as an example, like Dolly. She had arthritis really bad from her mother. Now, say we went from a perfect sheep and we got its DNA and we cloned it. We could even take out some of the traits that are like fine right now and we could make them better.